good morning. We have developed a system called nitrate assistance, and my name is Harish Anand, and I am from Mahatma Gandhi Public School, Chottanikara from Ernakulam. And let me introduce my friends.
I am Jacob Sabu from MGPS Ambadimala, and I am in 11th standard.
I am Argis Matai from the same school.
Now this is a very sophisticated system and a cutting edge technology that we have used here. Now we know a fact that in India, in every hour, 14 persons die of road accidents. This is a very alarming issue, and the one way we can solve this is to have a system that can dim the light automatically. Let's say, for example, here you can see that the light automatically dims. This functions on a LDR, light dependent resistor, where the resistance of that LDR decreases once the light falls on it, and then there is a microcontroller used in it. Now you can clearly see that once the light falls on the LDR, there is a dimming of light. This can actually save many lives and can be implemented in vehicles. Then the major aspect of it is that you can actually see that even in the street light situations, or even having neon lamps and all such situations, we can find that the LDR actually absorbs the light only from the opposite vehicle's car. That means LDR functions on the intensity of the light, and thus it does not include the lights from other sources like the street lights and the from the neon lamps, etc. So it's very efficient, and also it can bring a better system as well to the vehicle concerned. More than that, then the idea that we like to bring forward is that when you have a system that must bring everything into the road aspect as well. If you take the case of a highway where we are moving at night at very high speed, then the car passes off very fastly. So at that point, it would be better for us to have a system where the delay of it will be very short, so that it comes back to high beam very fastly. Let's see the case. Here there is a 4-second delay. When we are going in a highway traffic, we don't need such a delay. Instead, a delay of very short span is required. So to have that, we are creating a switch case statement where we will have, if the vehicle goes beyond 80 km per hour, then the delay of that vehicle, delay of the LDR will be made less than 3 seconds. So such a system can actually enable us to have the come back to high beam very fastly. Also, it can be very useful in high traffic situations as well. Let's say, for example, in a situation where we are in a city, there will be high traffic. So at that position, I'll show you the example. We will have the dim here, but then we need such long delays because of the fact that we have a motorcycle or something coming by. It requires that long delay, so that it won't give that quick flash which can have a precision on that driver of that motorcycle. That's very useful, so that it can actually save the lives of motorcycle vehicle as well as that of the drivers of this vehicle as well. Now, the better aspect that we have provided is the safety concern. Safety that we have found from the lack of safety that we have found from Delhi is that out of 5 accidents that happen at Delhi, 2 of them are caused simply because of high beam glare. Once we implement this system in that vehicles, or completely in every vehicles as a mandatory case, then surely we can reduce the accidents rate. It has been recorded of more than 1,000 in Delhi, and others as about Bangalore with 757. Next idea that we brought, or next module that we
Next, we have to introduce a new system that's called light diagnosis. This system will continuously check whether any light is damaged, or any of the components like lights or horns are damaged. In a situation where any light is damaged, look, For example, one of the light is damaged, so we can hear a beep that shows any of the like components like headlight is damaged. In this with this buzzer we can understand that there is a repair for any of the components of the light. Then next component is AC, automatic AC. This device saves energy. Like in a situation where we need to open a window or open a door, the AC will be switched on. But now we are providing a system which, if you are opening the door or window, the AC will be shut down, and if you are closing, the AC will come back to the on. Next we are going to introduce a system called.
This is the integrated unique toll booth system. In this system, toll booths work by using toll cards, which is kept in a car. This toll card is also called the RFID. In every toll booth, there is an RF reader which reads the details of the RFID, and the thing checks whether there is balance, and if there is balance, the block will be removed. After, when the car passes, there is an IR detector, so that when the car passes the IR detector, automatically the block comes back. The main factor is that we can implement this technology in connection with the GSM technology. If we implement this technology using GSM technology, we can recharge our toll cards by using mobile phones, and we can check the balance using mobile phones. Another advantage is that this toll card also acts as a personal ID to the car. If the car gets lost or a robbery takes place, we can find our car by using this system. We can use the server to find which all toll booths have the car passed, so that we can get a route map, so that we can find the car. Thanks.